And now we are going to discuss about electric potential today. Okay. We are going to discuss about electric potential now. What is the electric potential? As we have discussed in our previous classes, electric potential is a scalar quantity. Electric potential is a scalar quantity which gives some ideas regarding the properties of charge, properties of the field of any charge. Are you clear? But now, today in electric potential, we will understand about the proper definition of this electric potential. And remember that this electric potential helps us to calculate the electric potential energy. Okay. Electric potential is a property of a point inside a field, basically. So please try to write the definition of the electric potential here. Electric potential at a point. Electric potential at a point is the work done by external force in carrying unit positive test charge from infinity to that point against electric field without acceleration. Okay, this is the definition of electric potential here. Now try to understand, we are taking a positive charge here, and this charge you can consider as a source charge also. This is your source charge. Source charge. Okay. Now, what will happen if you put a charged particle inside this, inside the field of this charge? Can you tell me? What will happen? Suppose that we have chosen a point P here, and what will happen if we put a positive test charge at this point P? Nawal, can you tell me please? Hello? Hello? Matthew? Matthew, are you understanding or not?
Yes,
can you hear me? What will happen when you put a positive test charge at the point P? Remember that this point P is taken out in the field of this positive capital charge. Are you clear or not? So if this point is lying in the field of this positive test charge, then we, in the field of this positive charge, then you can easily say that when you put a point charge at the point P, then this charge will try to repel that test charge. Are you clear or not? In away directions. Are you understand or not?
Okay, sir.
Now, here we are defining electric potential. According to the definition, electric potential at a point is the work done by external force from infinity to that point in that field. Are you clear or not? So if you are choosing a point at this location, you can take this point is at infinity. And now at infinity, we can consider that the potential at infinity is 0. Are you clear or not? Because if the potential at this point infinity is 0, then we can say that when you transport a charged particle from this infinity point to the point P inside the field, one second, when you transport a charged particle, I mean test charge particle from infinity to this point, then can you tell me what will be the amount of force acting upon this charged particle? I mean test charge particle. Can you tell me? Then this positive charge will try to repel this test charge in away direction. Are you clear?
Yes,
And
sir.
this is the force acting upon this charged particle is said to be the F of electric, or you can say this is your F of conservative force. This electric force behaves here as a conservative force. Are you clear or not? Now,
Yes, sir.
just one second, just one second. 1 second, please. Everything is clear, but we are taking this point in the straight way. You are carrying from this. This is your infinity point, and potential at this infinity is 0. And now we are transporting a charged particle from infinity to the point P here. Okay. Now the net force acting upon this charged particle due to this positive charge or source charge, you can say, in away direction. Are you clear or not? In away
Yes.
direction. Okay. Remember that we are transporting this charge in such a way that the charged particle should not be accelerated. Okay. If there is acceleration is available, then what will happen? What will happen if your charge becomes accelerated? Then some extra types of energy are developed here. Are you clear or not? But we have no any requirement of that type of energy. So remember that while transporting a charge from any point inside the field from one to another point, remember that charge should not be accelerated. Are you understand or not? This force is your conservative force, or you can say electric force also. Are you clear? But we are transporting this charge by applying an external force against this force. And against this force can be drawn in such a way that this is your F external. Are you clear or not? This is your external force. Are you understand? Nawal.
Yes.
Hello? Nawal, hello. Can you hear me? Hello? Hello? Nawal, can you hear me? Matthew?
Yes, sir.
Matthew, is it is clear? I think Nawal is not
Yes, sir.
hearing. Just 1 second, give me, I am going to message.
Yes, sir. Sorry, my Wi-Fi was not working.
Okay, all right, no issue. Okay, and now we can consider that this point is at R separation from the source charge. Are you clear or not?
Yes, sir.
This point P is at R separation from the source charge. Then we can say what is your potential difference here? We can write here potential VA, sorry, V at P. 1 second. This is your V at P. Potential at P is greater as compared to the potential at infinite. Are you understand or not? Potential at
Yes,
P
sir.
is greater as compared to the potential at infinite. So we can write here your potential difference, your delta V. Just 1 second. We have this equation, delta V is equal to minus of W external. W infinity to P external over Q. What is your delta V? Delta V is your Vp minus V infinite, which is equal to W of infinite to P externally over Q. This is your equation number 1. Sorry, not this is your equation number 1. And now we have already know potential at infinite is 0. So we can write here Vp is equal to W infinite to P external over Q. This is your equation number 1. And now what will happen if your value of Q is 1 coulomb? When you put Q is equal to 1 coulomb, you get Vp is equal to W external, sorry, W infinite to P externally, W infinite to P external. Are you clear or not? This is your equation number 2. Are you clear till here?
Yes.
Yes, sir.
Okay, good. Note it down, please. What are the main points while calculating electric potential due to this point charge? Can you tell me? The main point is that your charge always been carried out from infinite to a particular point P inside the field. Remember that. Are you clear, Nawal?
Yes,
Your
sir.
charge is transported from infinity to point P. Okay. The second main point is that your charge should not be accelerate while transporting from infinity to P. Are you clear or not?
Yes.
If
Yes,
your
sir.
charge is accelerated, then some amount of kinetic energy also generated, because we have already know due to the motion of the charged particle, kinetic energy develops. Are you clear or not? Okay. So remember that your charge should not be accelerate. Okay. Hence we can say your charge at point P, while transporting your charge from infinity to P, always be in equilibrium condition. Are you clear? I mean Fe for equilibrium you have already know. In equilibrium, your charge should be in equilibrium. If your charge is in equilibrium, then remember that your F external must be equal to in magnitude of F of electric. Are you clear or not? Okay.
Yes, sir.
Yeah, this is the most important conditions here. Okay. Have you noted it?
Yes, sir.
Okay. Now we got Vp, I mean potential at point P. Okay. We have got it here. Potential at point P is W infinity to P external. We got here. Okay. And now, can you tell me what is the value of W external? Do you remember or not? Do you remember it? We have W infinity to P external is always be equal to integration of infinity to R. This separation is taken here as R. Okay. And the another distance is infinite. Are you understand? So we are taken here infinite to R, Q into E dot dr. And you have already know when you are okay while transporting this charge from infinity to P, your R decreases. R increases or decreases, Nawal, while transporting infinity to P? Your R is decreases or increases?
Increases.
Sorry?
Increases.
R in the sense position. Position of charge is increases here or decreases while transporting charge from infinity to P? You can look at here. This is your infinite separation. Are you understand or not?
Yes.
This is your at infinite separation. When you are carrying this charge from this position, then you can say when you reaches at here, your R is less than infinite. Are you understand or not?
Yes.
Hence, we can say while going from infinity to P, your position R is decreasing. Are you clear?
Yes.
Yeah. Uh, when you move this charge from point P to the point, suppose that we are considered here, okay, any another point N. Now your R is equal to this R or less than this R. What will be your position when you transport this charge from point P to this point N?
Equal.
Your R is decreases or increases? Hello? Nawal.
Yes.
Nawal, can you hear me? Can you tell me please? Your R is decreases or increases if we are going to transport P to N, this charge. Suppose that. This charge will, this position will increase or decrease?
It will be the same.
No, decrease. Remember here, this position is measured from source charge Q. This is your source charge. Are you clear or not?
Okay, yes.
Suppose that you have a point P here, okay? And we have another point at this position N. Now, when you move from P to N, your separation, you can say separation or distance from Q is decreases or increases?
Decreases.
A person is at point P and the another person is at point N. Which one is closer to the charge Q?
N.
N. Okay. In another way, we can say person at N is at person at N is at less distance as compared to the person at P. Am I right or not?
Yes, sir.
So in terms of charge, while transporting charge, when you transport this charge particle from P to N, then can you tell me this position will increase or decrease? Suppose that this is your position R1 and this is your position R2. Then can you tell me R1 is greater or R2 is greater?
R1.
R1 is greater. Exactly. Okay. I hope now you are understanding. Okay.
Yes, sir.
Yeah, good. So we can say your R is decreasing here. All right. When R is decreasing, then we can take here a negative sign. We can take here a negative sign. And this negative sign, in the previous lecture, if you have remembered, we have taken at this position, QE minus of QE dot dr. Do you remember or not? Matthew.
Yes, sir.
Matthew, can you hear me?
Yeah, I can.
Do you remember this equation, Matthew and Nawal, both? All
Yes,
of you
sir.
remember this equation from previous class? Just 1 second.
Yes, sir. Electric potential difference.
Exactly. This is your work done. Okay. Now, what is the significance of negative sign here? Negative sign represents that when you are moving, okay, towards the source charge. Remember here, we are going towards the source charge. Are you clear or not? We are going towards the source charge by applying external effort. This is your external effort. Are you clear?
Yes, sir.
This is your external effort. So we can say while transporting a charge from one point to another point towards the source charge, okay, by applying external effort, your separation R always be decreases. Are you clear?
Yes.
Okay. So we are taking here this, this negative sign represents your R is decreasing. I mean, separation is decreases. Are you clear now? Are you clear now, Nawal?
Yes, sir.
Okay, good. Nawal, ask me freely. Okay, there is no any issue. You can ask me any question. If you are not understanding, okay, I can repeat the topic. Are you clear or not?
Okay, sir.
But please tell me. Are you understand?
Yes, sir.
Yeah. If you are not in the okay understanding any one of the topic, you can easily tell me. I will try to repeat it. Okay.
Okay, sir.
Yeah. This is your minus of q e dot dr. All right. Now, this is your, I think this is your equation number 2, right? Yeah. This is your equation number 2, and we can take it equation number 3. Now put this value, I mean this value in equation 2. Put 2, sorry, put 3. This is equation 3 here. Put 3 in equation 2. When you put this value, you get V at P is equal to, V at P is equal to, what is your equation? V at P is equal to W of, just one second, put this value in equation not to 1. This is the equation 1 here. Okay. W of infinite to P external, infinite to P external over Q, and when we put this value, we get minus integration of infinite to R Q into E dot dr over Q. Q and Q cancel each other, and we get V at P is equal to minus of integration infinite to R E dot dr. Are you clear till here? Are you clear till here or not?
Yes, sir.
Nawal and Matthew both.
Yes, sir. Clear.
Yes, sir.
So this is your value of electric potential. This is your value of electric potential at point P. At point P inside the field of charge plus Q. Are you clear or not? This is your value of electric potential at this point P of the charge capital Q. Are you clear?
Yes, sir.
Okay. Second point, which is important to notice here. Again, in the final equation, we get a negative sign here. In final equation, we can see here, this is your negative sign. Are you clear or not?
Yes, sir.
Yes, sir.
What is the significance of this negative sign? What does it represent? It represents while going from infinity or any, infinity to point T towards the source charge, okay, your potential, your field is decreases. Are you clear?
Yes, sir.
Yes.
Yeah, we can take, or just one second, we will understand in the next topic here. Just for remember, you should remind that this negative sign represents that your separation is decreases here. Are you clear? Your separation is decreases. Okay. And we have already know this is a scalar quantity, and the SI unit, your SI unit is joule per coulomb, or sometimes it is also called volt. Okay. Remember, please note down an important note here. Note accelerated charge will generate accelerated charge will generate electromagnetic waves. Okay. Electromagnetic waves also. Note it down, please, all of you. This is a very important point. Very, very important equation. We will use this equation for the in solution of questions. Okay, in further. Please note it down. Have you noted it?
Yes, sir.
Yes.
Okay. Next one. Yeah, we are going to take some questions now. Please write down. Electric field in a region is E is equal to A over x cube I cap. Calculate potential in this region. Calculate potential in this region. Note it down, please. Matthew, what is the syllabus covered in your school? Can you tell me?
So
Which one
first three
topic
chapters
is?
are over.
In topic you are? Sorry?
First three chapters are over.
First 3 chapters are over. Okay. And Nawal?
First 4 chapters are over.
Oh my God. First 4 chapters are over. In how many time?
We finished the 4th chapter last week.
Last week. Okay. In your school, how many questions are generally solved with the concepts?
Around 10 to 20.
Around 10 to 12. In whole of the chapters or within a...
Of every chapter.
In every chapter, hardly?
Like
8 to 10.
Yeah.
Okay, okay. All right. But we will try to solve a lot of questions, okay, in the class to prepare your board exam properly. Now, let's go on the question now. Any one of you can solve it or not? Matthew?
Sir, what will DR be? E is given, but what will DR be?
This is the main point, okay, to understand about the DR here. Okay, Nawal, are you understanding this question?
Yes, sir.
Can you solve it?
No, I can't, sir.
I think this question is taken from the NCERT book. All of you are using NCERT book in your schools?
Yes.
Okay. This question is taken from the NCERT books. Okay. Now, let's try to understand here. your value of E is A over x cube to the power I cap is given already in your question. Are you clear? This is your given value. Okay. Now, what is the equation of potential? We have already know. 1 second. This color is very, very light. The equation of potential is V is equal to integration of E dot dr from infinity to R. Okay. Minus of integration from infinity to R. Look at here. Nawal. Okay.
Yes,
Try
sir.
to understand here. Here we are taking the limit from infinity to R. Okay. But in this question, your variable are taken in terms of x. So we are going to take from infinity to x now. Are you understand?
Yes.
Yeah. Because you can look at here, your value is given in terms of x. Okay. So we are taking here x. E dot dr. What is your value of E now? We have already infinite to x, a over x cube I cap. And what is the value of dr? Dr is your variable. Okay. But our values are given in terms of x. So again, we are going to change it. We are taking here dx. Okay. And we know if your electric field is along I direction, so we can say this is your I and this is your J, and electric field is along this direction. Are you clear? If your electric field is along this direction, then we can say when you put a charge in this direction, your charge will displaced in the same direction I cap. Okay. So your displacement also be taken here along the direction of x-axis. Okay. And we can write here dx I cap. Are you understand, Nawal?
Yes, sir.
Nawal, any issue?
No, sir.
Matthew, are you understanding why? Okay, how can we take in here dx I cap? Why we are taking here?
Yes, sir. Understood.
Okay, why? Because your field is directed along the plus x-axis. Okay, and if your field is along the plus x-axis, then we can say your displacement vector also will lie in the same directions. Okay, and we can take it also dx I cap. Are you clear or not? This I cap and I cap both are operated here with the dot product, and after taking dot product, you can write here infinite to x a over x square, sorry, x cube is given, x cube dx. I cap and I cap, we have already know. I cap dot I cap is always 1. Do you remember or not? Nawal, are you understand till here?
Yes, sir.
Okay. And now, your A, capital A is constant here because differential part is your x. Okay. Here, the differential function is in the x term. So A is constant and we can take it outside from the integration infinite to x. Here we have only 1 over x cube dx. And finally, we can write A after integrating 1 over x cube. Before integration, first of all, we should try to write down 1 over x cube in the proper form of integration. We can write it x to the power minus 3. Okay, x to the power minus 3 dx from infinite to x, and A x to the power minus 3 after integration. You have already know if there is x to the power n, after integration you get x to the power n plus 1 over n plus 1. Do you remember this formula of integration? Nawal, do you remember?
No, sir.
This is your, okay. Have you mathematics in your class 10?
No, sir.
Okay. All right. Don't worry. Just try to understand here. I am going to teach to you. To tell you. 1 second. Remember that in integration, okay? Integration. What is the integration? Integration is generally an increasing function. Which type of function is integration? Integrating function. Sorry, increasing function. Integration means to sum up. Okay? Integration in the sense to sum up. Are you clear or not?
Yes, sir.
And a common formula is that to solve such types of values, okay, just like in this equation, we have a formula here. If there is a x to the power n is given, okay, then after integration it will be x to the power n plus 1 over n plus 1. Are you clear or not? This is the formula
Yes.
of the integration. Okay? Are you okay or not?
Yes, sir.
So, if you see in this equation, 1 over x cube is not in a proper form of the integration. Are you clear or not?
Yes, sir.
So, first of all, we will try to change this value, this form into the proper form. And when you are carried out this x cube from denominator to the numerator, it will be x to the power minus 3. Now you can say this value is in the proper form of this value. Are you clear? Now we
Yes,
can
sir.
integrate. Hence, after integrating, this is your x to the power n. What is the value of n here? Value of n is minus 3. Am I right or not?
Yes.
This is your value of n. We can write here x to the power minus 3 plus 1 over minus 3 plus 1. Okay? From infinite to x. After integrating, you get a x to the power minus 3 plus 1 will be minus 2 over minus 3 plus 1. Just 1 second. There is a negative sign also, I think. Yeah. There's a negative sign also. Okay. Write down here negative sign also. Okay. Negative sign. X to the power minus 2 over of minus 2. From infinite to x. 1 second. Please note it down till here. I hope, Nawal, this is clear.
Yes, sir.
Okay, any issue? Honestly speaking, is it
Yeah,
clear?
yes, sir.
Okay, note it down, please. Have you noted it?
Yes, sir.
Wait, sir, wait. 1 second. Yes, sir.
Okay, good. Please, all of you, okay, open your cameras, please. Okay, it is better for interactions, basically. Now, what is your last point? Yeah, we get here this value. Okay, Yeah. We have now V is equal to minus of A over, we can write it minus of 2 also, x to the power infinite to x. Now, in such types of values, Nawal, especially for you, suppose that you are going to solve such types of value x to the power a to b. Okay, this is your upper limit. Okay, what is this?
Upper limit.
This is your upper values or upper limit, you can say, and this is your lower values or lower limit. Okay, then
Yes.
we always put upper limit first. Okay, then lower limit. Okay, and we will subtract them with each other, just like x, sorry, at position of x, first we will put b, then we put a, and we will subtract them, and finally your value will be the final answer what you have get here. Are you clear?
Yes, sir.
Yeah. Now similarly we are going to do in this part, this minus will cancel with this minus, you get a over 2. At the position of x, first we put x, then your value is unchanged, minus infinite. We get a to the power, a over 2 into x. This is your, 1 second, please. No. It is your x square here. We have left here x square. Yeah, x square. We get here x square. And now, if it is x to the power minus 2, we can write it a over 2x square. This is your final answer of potential. Matthew, is it clear?
Yes, sir.
Nawal, any issue in this
Yes.
question?
No, sir.
Such type of questions you have solved previously or not?
No, sir.
No? Simple types of question you have solved in your school, I think, right?
Yes, sir.
Yeah. But don't worry, okay? We will try to solve a good type of questions in the class, okay?
Okay, sir.
Have you noted it? Note down, please. Matthew, have you mathematics in your 12th?
No, sir.
Sorry?
No, sir, no.
Okay. Then you are also having no idea about the calculus, I mean differentiation, integration.
Sir, our physics teacher in 11th grade discussed about this formula, this x raised to n plus 1 by
Okay,
n plus 1.
just only formula is okay discussed.
Yeah, only that.
Okay.
In
Can you
11th.
all of you please both of you open your camera, please. Both of you please open your camera.
Sir, can I do it from next class?
Okay, all right, no issue. Just listen me, please. Can all of you can tell me, you can integration concept or algebraic concept or any other concept?
So can you repeat? I couldn't get
Suppose
that.
that, okay, I am giving you a situation. Okay, I am giving you a situation in which how can you recognize that there is calculus is applicable or algebraic formula is applicable? How can you understand it? Have you
Integral,
any idea?
there are integrals involved.
Sorry?
If there are integrals involved.
It?
Integral, if they are involved.
No. Just I am asking to you, how can you understand your calculus method is applied or algebraic method is applied? Nawal,
Yes.
can you tell me please? Do you know about any information about it or not?
No, sir.
No. Okay. Remember that it is a big issue with all of you. I hope Matthew and Nawal, both of you, are facing a big problem while solving the physical calculations. Am I right or not? Especially in
Yes.
physics, while solving the
Yeah.
numericals or any derivations in which the integrations are involved. Are you clear or not?
Yes, sir.
Yeah. So if all of you are agree, then I can give you one class in which I will try to clear all of the concept. How can you understand or how can you recognize from the given condition your integration is involved or any other method of the uh, mathematics is involved? Are you clear or not?
Yes.
If all of you are
Yes, sir.
agree.
Yes.
Can you take it now?
Sorry,
Can you take it now?
when?
Now.
Now, just now.
Yeah.
Oh, okay. But don't worry, because in today's lecture, most of the time is passes now. I think how many times we have?
40 minutes around.
Yeah, around 40 minutes we have, which is very small time. Okay, because it may take around 2 to 3 hours. Are you clear?
Yes, sir.
It may take 2 to 3 hours for your proper informations. Okay. Now, have you noted it or not?
Yes, sir. No.
Yes, sir.
Okay, good. But don't worry, I will give you the whole of the ideas, okay, in small parts in 2 to 3 lectures, okay, and I will try to cover it. Now we have a question, another question. Please note it down. Calculate VA minus VB, and some fields are given like this. These are making 45-degree angle. Okay. These are making 45-degree angle. Now, can you solve it? Can you solve it or not?
No, sir.
This is your point A, and it's your point B. Okay. Now we have an equation already. VA minus VB is equal to minus of E dot minus of E R of BA. All of you are remember this equation or not? Some other values are given like This is your electric field and it is of 10 Newton per Coulomb. And the separation between A and B is 5 meters. Okay?
Okay, sir.
Yeah. All of you can solve it now.
Yes, sir.
What is the potential at A? Oh, sorry, there is no need to put here VA and VB because it is already asking in your question VA minus VB is asking here. So we can write now the VA minus VB is equal to minus of E vector dot R vector. Okay. This is your RBA is the displacement vector basically from B to A. We can write it minus of E RBA cos theta. Can we write it or not? Nawal, do you remember this formula? Vector A dot vector B is A, B cos theta because they are operated from the dot product here. Are you understand, Nawal? Okay.
Yes, sir.
So we are using this formula. Okay, here. Now you can write here minus of E. What is the value of E, which is given here 10 Newton per Coulomb into RBA. What is the separation between A and B? This is your 5. The separation between A and B is 5. Cos theta. Cos theta. What is the cos theta? Matthew, I am asking to you. What is the cos theta?
Cos theta, cos 45. Yeah,
How can you take it cos 45 directly?
it's given the question.
Hmm?
It's given there, right?
No,
45.
no. Uh, remember that your axis, your angle is always measured in anti-clockwise. Do you remember or not? Okay. Angle. What is the rules of measurement of angle? The angle measurement rule is always in anti-clockwise. Are you clear?
Yes.
Nawal?
Yes, sir.
Yeah. So can you tell me what is this total angle? Just 1 second. 360 minus. Yeah. We can take it cos 360 minus 45. Can we take it or not?
Yeah.
This whole of the, just 1 second. This whole of the value is 360. Okay. But in 360, it is 45. So we can take it 360 minus 45. Okay. And 360
Yes,
minus
yes.
45 is again converted into the same values. And we get minus of 10 into 5 into minus of cos 1 second 45 again. Minus and minus will be plus. This is your 10 into 5. What is a cos 45? Cos 45 is 1 by root 2. Okay. Finally, you get 10 into 5 is 50 over root 2. 50 over root 2. Or sometime you can also write it 50. 50 you can write it 25 into 2 over root 2 or 25 into root 2 into root 2. Because we can write root 2 into root 2 is equal to 2. Is it is true or not, Nawal?
Yes, sir.
Okay. Over root of 2. Root 2 is cancelled with root 2. You get 25 root 2 again. Volt. Is it is clear?
Yes, sir.
Note it down, please. Have you noted it?
Yes, sir.
Yes, sir.
Next one, electric potential. It is the next heading. Electric potential due to a point charge. Electric potential due to a point charge. This is a next heading, which is very, very easy to calculate. Okay. All of you have noted it?
Yes.
Okay. In this, we have a positive charge Q. This is your positive charge Q. Okay. And the field, inside the field of this positive charge, we have any other point P. We have any other point P, where we want to calculate the electric potential. And in case of electric potential, if you want to calculate at any particular point, then you have already know we can't calculate it without any other reference point. So while calculating potential, you must have 2 points. Okay. One of the point P is given here and the second point is not given. So we will choose the another point at infinity. Are you clear or not?
Yes, sir.
We will choose the another point at infinity at which we have already know potential is 0 at infinity. Okay. Are you clear or not?
Yes, sir.
Now, before, now we are going to take one another point at infinite position. This is your infinite position. At this infinite position, your potential is 0. Are you clear? Your potential is
Yes.
0. Now what will happen? Once again, we are going to do the same work as in the previous heading. Okay. We have taken up unit positive test charge. Okay. Which is carried out from infinity to this point P in such a way that it should not be accelerated. Okay. We are carrying a unit positive test charge from this infinity point to the point P in such a way that it should not be accelerated. Okay. And now if it is not accelerated, then how it is possible? We have already know at this point P there is a conservative force is applicable here. This is your F of conservative, and the another force through which you are transporting this charge, I mean from outside, just like you can consider that I am available at this point infinity and I am carrying this unit positive test charge from infinity to a particular point P by applying some external by applying some external effort. Are you understand or not, Nawal?
Yes, sir.
Okay, we are carrying this charge particle from infinity to point P by applying some external effort. Okay, when we are applying some external effort, then that effort must be in magnitude of comparable to the FC. Okay, why? Because if it is comparable to the FC, then we can say that FC and your F external are equal. And if they are equal, then we can say, one second. then we can say in equilibrium, F external is minus of F of C. Are you clear? Now, you can also take as the separation from Q to point P is R. Are you clear or not?
Yes, sir.
When your charge is carried out from infinity to point P, then now your charge is at point P. Now, can you tell me what will happen? I think this positive charge try to apply a force upon this unit positive test charge, and that electric force will be noted down here. The electric force on charge of 1 coulomb due to plus Q charge, which is your F of electric is 1 over 4 pi epsilon naught Q into Q, and this value of Q is taken as 1 coulomb here. So we are directly considered here 1 only. Okay. It is your Q over x square. This is your equation number 1. Are you understand or not?
Yes.
Are you understand or
Yes.
not? So
Yes.
we have calculated the amount of electric force acting upon this charged particle at point P. In the second case, when a force is applied upon a body, okay, then can you tell me the body will displace or not? Sorry, when you applied a force upon the body and body is displaced, then we can say there must be a work done. Okay, a work has to be done because the condition of work done is W is equal to F into S. When a force is applied upon a body and the body is also displaced, then you can define a work here. Are you clear? Then what will...
Yes.
So please note it down. Work done by external force in carrying 1 coulomb charge. Okay. From, you can take here an elementary part of dx. This is your C and this is your D, from C to D. Okay. I will tell you what is the reason behind to take this dx here. Okay. This is the elementary part. First of all, your dw will be equal to the f of external dot dr. Am I right or not?
Yes, sir.
Okay. This is your equation number 3. Just 1 second. 1 second, please. Take it your equation number 1, and this is your 2, and this is your 3. Okay. Are you understanding, Nawal, till here?
Yes, sir.
Okay. Now put your values. Put your equation number 1 in 3. This is your FC or FE. Remember that F electric is also behaves like a FC, which is your conservative force. Okay. So put equation 1 in equation 3. We can write dW is equal to F of electric dot dx. F of electric dot dx. Are you clear? This is the minus of F of electric because there is a minus sign also. Okay. Now, what is the work done? In carrying one coulomb charge from infinity to point P, we know W is equal to from infinity to point P. This is an infinite to R minus of F of electric dot dr. Now you can put all of the given values from infinity to R. F of electric. What is your F electric here? F electric we have already know. Sorry, we have already calculated here. This is your F electric value. You can put it here 1 over 4 pi epsilon naught Q over x square. 1 second. Q over x square. This is the dx, not dr. Into dx. Okay. Till here, everything is clear.
Yes, sir.
Yes.
Matthew and Nawal.
Yeah.
Everything is clear.
Yes, sir.
Note it down, please. Have you noted it?
Yes, sir.
Hello.
Yes, sir.
Yes, sir.
Okay, good. Now we have W is equal to, what is the last equation here? Minus of 1 over 4 pi epsilon naught. Okay. Now you can look at here 1 over Q over 4 pi epsilon naught is constant term. You can take it outside from the integration. This is your negative sign. 4 pi epsilon naught. Integration of 1 over x square dx from infinity to r. This is your W. Okay. Now, Nawal, I am just asking to you, can you tell me, can we integrate this function or not?
Yes.
How? Can we integrate it directly or not? No. Do you remember why? Nawal.
Yes.
Do you remember why we can't integrate it? Because it is not in the standard form.
Yes.
Okay. I have
Yes,
already told you in the previous, before some time. Okay.
Yeah.
What is your standard form? This is your standard form. Okay. After integrating, you get n plus 1 over n plus 1. Right. So first of all, we will try to change it in the standard form, and we get q over 4 pi epsilon naught integration of infinite to r x to the power minus 2 dx. Are you understand? Now it is in the standard form, right? Then minus of q over 4 pi epsilon naught. After integrating x to the power minus 2, we get x to the power minus 2 plus 1 and minus 2 plus 1 from infinite to r. Again, we get q over 4 pi epsilon naught x to the power minus 1 over minus 1. Are you understand?
Yes.
Good. Now, what is your w? W is your, this negative sign and this negative sign will cancel each other, or you can say it will become positive. You get q over 4 pi epsilon naught x to the power minus 1 from infinite to r. First of all, we are going to change it in this format. X to the power minus 1 can be written as 1 over x from infinite to r, and q over 4 pi epsilon naught. This is 1 over x will be 1 over r. Finally, we get 1 second, 1 over r minus 1 over 0. Oh, sorry, 1 minus 1 over infinite. You get q over, 1 second, you get 1 over 4 pi epsilon naught into r. This is your work done, w. Okay. And now this work is potential at that point. So we can write it again. V is equal to, you can write it, V is equal to, W is equal to Q over 4 pi epsilon naught R. Are you clear?
Yes, sir.
Yes.
Good. Note it down, please. Have you noted it?
Yes,
Yes,
sir.
sir.
Good. Next point is, remember here, yeah, in this, yeah, next point is also write down in the same part, potential of a positive charge is positive, and that of a negative charge is negative. Okay?
Yes, sir.
Yeah. Due to positive charge, potential will be positive, and due to negative charge, your potential will be negative. Okay? From this equation, you can look at here, V is directly proportional, sorry, V is inversely proportional to R. So we can draw the graph of this part. Like this. This is your R, this is your V, and it is inversely proportional. So the graph will be hyperbolic. Okay.
Yes.
This is also used for positive charge. For positive charge. Or you can say for positive potential. Okay. When your charge is negative, then how can you do it? Then you can look at here again. This is your axis of R. This is your minus V. Along upward direction, it is your plus V. Along downward direction, it is your minus V. Are you understand, Nawal?
Yes, sir.
Matthew, this is your R.
Yes, sir.
And now again, your graph will be parabolic, but in this quadrant. This is for negative potential. You can write potential or charge, both is correct here, okay? Is it clear?
Yes, sir.
Yeah. So this heading is over today, and we will continue it from the next heading in the next class. Before over this class, I am going to give you some glimpse to understand how can we use the proper concepts of the mathematics, okay, at the given conditions. Okay, note it down, please. But I think your time is also over. So we will, okay, I will give you the information about the mathematics in the next class. Okay?
Okay, sir.
Okay,
Nawal?
sir.
Yes.
And yeah, Nawal and Matthew. Any issue? Is
No,
today's
sir.
concept is clear or not?
Yes, sir.
Yes,
Today's
sir.
concept is clear.
Okay, good. Have you noted it?
Yes, sir. Yeah.
Yes, sir.
Okay, all right, good. So we will meet in the